Hi everybody. In this video I will be talking to you about one of the theorems about chords related to circles. In this diagram you can see that I have a circle with two intersecting chords. Now this chord here, CD, is intersecting with this chord over here, AB. And the place where they meet is of course right here at point X. Now when this happens, you end up with four segments. You have a segment right here. You have a segment right here. You also have a segment right here and a segment right there. Okay. Now I know this looks pretty messy, but I'll clean it up in a second. But the relationship between them is the following. So AX, the product of AX and XB would be the same as a product of CX and XD. Okay, AX times XB ends up being the same value as CX times XD. And that's really it. That's the whole idea behind this. So with that in mind, let's go ahead and jump right into an example to see how this works. So in this example, it says, in the circle shown, what is a measure of X? Show your work. Now, you can see that we have two chords, just like in the diagram above, and they intersect at a certain point, which is right over here. That really doesn't matter too much. Actually, it doesn't really matter at all when we're trying to figure this out, but it's noteworthy anyway. What we need to do is we have to figure out the value of X. Now, the way to do this is to just apply the principle that I laid out for you over here about those two chords and the four segments created by their intersection. So doing that over here, what we get is the following. We get X times X would be the same thing as multiplying 4 times 49. Now 49 times 4 is 196. Okay, and X times X would be X to the power of 2. Now, to solve this, we have to apply a little algebra skill. So here we go. We're going to do the square root of both sides, which eliminates our square and our radical. That gives us a free X, and the square root of 96 is exactly 13. And that's our answer. So each of these values comes out to be 13 in this example. Okay, so I hope this helped you out. One thing I do want to note is that the fact that these two are congruent to each other doesn't necessarily mean that it's always going to be that way. It just so happened to work out this way in this case. But as you can see clearly, this value and this value are not the same at all. So those two segments are obviously not congruent. But it just so happened that these two ended up being that way. Okay, don't count on it always being like that though. Solve for it by the principle that I described above, and this will always work when you have two chords that intersect within a circle. So thanks for watching. See you next time. Bye-bye.